Diary, good evening. It's the beginning of April 2020 and you're looking at a part of our heating system in our house in England. The purpose of this video is to talk about heating systems in general and in particular our sticking Grundfos pump. So we've recently changed from a biomass system to an all-electric system. And up here you'll see there's on the left hand side is an all-electric boiler, and if we focus in on this pump, this is the main heating pump. So this is the main Grundfos heating pump, and hopefully this is going to work with my little ruler here. This is heating pump which is taking the cold water that comes in here, goes out of the boiler, down this tube, hot, past this isolation valve into the pump, and from the pump it goes to these three electrical switches. One is underfloor, can't see that, so it goes to these three switches. One is underfloor, one is hot water, and one is radiators. So these are electrical switches which, according to our computerized system, and many people just have a manual system with a manual programmer, will switch on those valves and allow the water to flow into either the underfloor, the hot water, or the radiators. Now, to go back to the pump here, this is a Grundfos UPS2 pump. The original was UPS1 in their design, and now they've got a more modern set of pumps. They've got a UPS3 pump. They've also got a range of alpha pumps, alpha 1 and alpha 3. I've signed up with the Grundfos website and done a bit of training, so I'm now an unofficial Grundfos salesman. Anyway, the point of the blog article and the diagnosis is that when you turn the heating system on, the heating system, the mains power here selects the pump, the mains powered pump. This wire just contains live neutral and earth, so all it can do is switch on and off this pump. The pump can't feed back to the heating system or electronic control system in any way. Anything about the pump's RPM or status. It can only switch on or off. So the pump is kind of acting on its own. So the point of the video we're going to show now is the pump not working correctly. So Alexa, turn on rail. Okay, so we told Alexa to turn on rail. It's going to talk to Heat Miser. Heat Miser is going to ask the boiler for demand. Boiler. Yeah. Do you hear the click? And it's now trying to start the pump. So, do you hear the click? I'll zoom in on that. So it's click, click. So what's happening is that the central heating system has been asked to start. The central heating system, via this wire here, starts the pump, or tries to start the pump. It doesn't know the pump's not started, so then the LED of this pump heating light goes on here. So now we're in a dangerous situation. The pump isn't pumping, but this column of water here and through the actual boiler is being heated. So the boiler is actually heating a static column of water which isn't moving, which is very dangerous. So what's going to happen is that the boiler is going to thermally cut out, because if it didn't thermally cut out, that water would turn to steam and there'd basically be an explosion. So we're kind of hopeful that the cut-out mechanism works, because this pump refuses to start for about 10 minutes. So at 10 minutes it just goes click, click, click. Now the way these pumps work is via a starting capacitor. So technically what might be wrong is that the electronics here, the electronics on the right hand side of this pump, contains a starting capacitor, and if that starting capacitor has gone FUT, then it doesn't quite have enough turning moment to start the pump. The starting capacitor, as you might imagine, is only used for the start of the pump. Once the pump's running, it's not needed. So it's my conjecture that the starting capacitor is buggered. So overall what happens is that eventually the heating system thermally cuts out, cools down a bit. It still has demand, so it's still trying to start the pump. Eventually, if we're lucky, the pump will start. Now the only reason we notice this is because the heating system is actually in the lounge in a cupboard. If this had been in a faraway place in a bigger house, we wouldn't have even noticed this, because eventually the pump does start so far, but it must thermally cut out multiple times, I'm guessing let's say 10 or 15 times, before actually the pump kicks into action. So what's the recovery plan? The recovery plan is to buy a new pump. You need to go to if you've got a Grundfos pump, you can go to the Grundfos website. You can look at the PC date, which is the manufacturing date here, and you can determine whether your Grundfos pump, this is a UPS2 pump, has a 5-year warranty, for example, or what kind of warranty it does have. And then you can actually get a new pump gratis from Grundfos via one of their authorised distributors. So that's what we're planning to do. So our plan is to get a new pump and fit the new pump. Now, it can be that a UPS3 pump, we haven't determined this exactly, but what we believe is that this pump is a front part and a back body part here where the impeller is. So we believe that the designs are interchangeable, in which case we just need to isolate the pump with these two isolation valves here, remove these 4 screws, take the front of the pump off and fit a new pump body, if you like, leaving the old UPS2 back part onto the system, which means to say that we don't actually have to take and make these new joints here and here. So that's our plan, in other words, to replace the failing part of the UPS2 pump with the front part of the UPS3 pump, and then all should work fine. And it's just one last thing, the debug steps before replacing the pump are, of course, to undo this screw here. Undoing this screw should remove any air that's trapped in the pump. And when you undo that screw, you should maybe get a bit of a dribble of water, but then the water should stop. In our case, the water doesn't stop, which means that the seal, which at the back of this pump, is also kind of defective. So when we took this screw off, we have a continuous stream of water coming out of here, and that's obviously not correct either. So that would be another indication that you need to replace the pump. And lastly, when you take this screw out, you can get to the actual mechanism of the pump, and with a screwdriver you can actually turn the pump, and if it's restricted, it means to say there's sludge in the system, or you've got some obstruction. So the first debug steps before replacing the pump are remove the air, check that the pump can turn freely with the screwdriver. If both those conditions are met, or if you hear this kind of ticking noise here, it means to say that the pump needs replacing. Okay, thanks for watching, Darren.